Okay, so this is our last conversation in chapter 2, and we've been talking about conversion factors and equalities and using conversion factors, multiple conversion factors, and so on. So here what we're going to talk about is using conversion factors in density calculations. This is kind of an application of conversion factors. So our learning goal is to calculate the density of a substance and to use the density to calculate the mass or volume of a substance, okay? So here's a graphic from our textbook. The density of cork is about 0.26 grams per mil, and that's why it floats. Water is 1 gram per mil, right? And so anything that's less dense is going to float, and anything that's more dense is going to sink, right? So lead sinks to the bottom, and aluminum even sinks, even though it's really not that much more dense than water, 2.7 grams per mil. All right, so here's a table from your textbook, and this gives some sort of reference points for densities. So the density in grams per mil of cork is 0.26. The density, these are solids over here, okay? So we have a wide range of solids. Oh, I'm sorry, a wide range of densities. Cork is 0.26. Gold is 19.3, right? Liquids in grams per mil. Water is 1. That's our reference point. We always reference everything to water. Urine is close to 1, right? Blood plasma is also close to 1. Milk is close to 1. Blood is close to 1. Mercury is not close to 1. That's a metal, right? And it's a liquid metal, and it's extremely dense. Gases we typically measure in not grams per mil, but grams per liter because they're way less dense, okay? Way less dense. Carbon dioxide, for example, which is 1.96, is actually, because it's grams per liter, is actually way less dense than water, even though the number itself is big, right? But that's because the grams per liter is different than grams per mil, right? So that's the reason why these gases, because they're so not dense, we typically use grams per mil, right? So let's look at density a little more carefully. Density compares the mass of an object to its volume, right? It's the mass per volume. That's what density is, right? So chemists oftentimes will measure density in grams per cubic centimeter, which is the same thing as grams per mil, right? Because cubic centimeter and a mil are the same thing, okay? For solids and liquids and densities of gases, those are so not dense that we typically use grams per liter for gases, okay? But that's what density is. It's simply mass per volume. All right, so the way that we measure the density of a solid oftentimes in a lab is we'll measure the mass by doing something like this. Measure the mass, just put it on a balance, right? And it's 68.6 grams, okay? And then we will measure its volume by the water displacement method, This is pretty cool. You guys have already done this in the lab, but you'll take some liquid. Water is the simplest and easiest thing to do. It's got blue food coloring in here so you can see it. But water, here's our zinc is here. We first of all put some water in there, and it comes out to 35.5 milliliters, right? And then we put the zinc in it. We drop the zinc in there, and the water level goes up, of course, right? We displace the water. And if the water level goes up to 45 mils from 35.5, then we take the difference between those two. The mass is 68.60 grams. The volume is equal to 45 minus 35.5, which is equal to 9.5 milliliters, right? And so if we're calculating the density then, we'll do this on the next page, but let me show it to you here. It's mass per volume. We simply divide those, right? 68.6 divided by 9.5 grams per mil, and this is going to come out to about 7.2. Okay? So here's this same, what I just now said, but written out a little more carefully. The density of the solid zinc object is calculated by dividing the mass by its volume, right? So first of all, we figure out the volume, and we knew the mass from the balance, right? So we do those, and sure enough, that's what we get. All right. So let's do another example. What is the density of a 48-gram sample of a metal if the level of water in the graduated cylinder rises from 25 mils to 33 mils, right? So volume is equal to the final minus initial, 33 minus 25, which is equal to 8 mils, right? So volume is equal to 8 mils. You can see why this is, right? This is very intuitive. Now, I wrote symbols here, which may be a little scary to some of you. I wrote V final minus V initial, and you might be like, wow, where did he get that equation? Well, all I did was I took the water level without the object in it. I put the object in, and it went up, right? And it's the difference between those two, which is what I wrote right here. It's just the difference, which is the difference is entirely attributable to that object in it, right? So it turns out it's 8 mils, and so the density is equal to the mass divided by the volume, which is equal to 48 divided by 8, which is equal to 6 grams per mil. And the final thing we're going to do here is we're going to ask what's the significant figures, right? So this had 3 significant figures. This had 3 significant figures, but you know what? No, it didn't. 33.0 minus 25.0 gives 8.0, which is only 2 sig figs. Aha! So this is 2 sig figs. This was a mistake. It's going a little too fast there. Okay? This is 3 sig figs. This is 2 sig figs. And so the answer can only be in 2 sig figs. And so it's going to be written as 6.0 grams per mil. If that was a little too fast, if you're wondering why I said 2 sig figs, then do that math right there. Go do that math and tell me what is the answer. All right, so let's do another example. If the volume and the density of a sample are known, this is our core chemistry skill. Core chemistry skill, using density as a conversion factor. If the volume and the density of a sample are known, the mass in grams of the sample can be calculated by using the density as a conversion factor. Okay? So let's do an example of that. Let me go back to red here. John took 2 teaspoons of cough syrup. Volume is equal to 2.0 TSP of cough syrup. If the syrup has a density of 1.2, density is equal to 1.20 grams per mil, and if there's 1 mil in a teaspoon, just a second here. Something's wrong here. Something's wrong here. Sorry, lost my marker. Why is that? I think I lost my marker. Oh, there you go. That's why. 1 mil is equal to 5. Nope, it's opposite. 1 teaspoon is equal to 5 mils, right? Now, the question is, what is the mass? All right, so I'm going to do this like we did before. The mass is going to be, what's the mass in grams, right? So what's the mass in grams? So I'm going to be doing a bunch of conversion factors. I don't know how many, right? But I'm given my volume was 2 teaspoons, 2.0 TSP, okay? And so my TSP is going to have to be on the bottom because I've got to cancel it out. So I'm going to come up here. I already used this number. That's number 1. Okay? But lost my... Okay? Okay, so look at this. Here's the one I'm going to use. Here's my first conversion factor, 2. I can see that teaspoons are related to mils, right? I'll put the numbers in last. Now my teaspoons are going to cross off, but I got to get rid of my mils. So my mils, I'm going to come up here and there they are. Mils are related to grams. And it looks like I'm not going to need that. So let's put the numbers in here and see how this works out. So I know that there are 5 mils for every 1 teaspoon, and it's 1.20 grams per 1 mil, and I've got 2.0 teaspoons. My teaspoons cross off, my mils cross off, and I'm left with grams, which is what I wanted. Okay? So 5 times 2 times 1.0. 5, that's 2.0 times 5 times 1.20, right? And let's do our sig figs. This has got 2 sig figs. This is exact. 5.0 mils. No, it's not. This is measured. This is exact. But this is between US, right? That's a metric, and here's US. So this is measured. That was 5.0 up there. Do you see it? So it's 2 sig figs because it's 5.0. See 5.0. Okay. And this is 3 sig figs. Okay. So it looks like my answer is going to have to be 2 sig figs. Okay. So 2 times 5 is 10 times 1.2 is 112. Well, that's it, right? Just 12. Because I'm only allowed to use 2 sig figs. So this is going to be 12 grams. That's how many grams I have of cough syrup. All right, let's do another example. Now, I'm strongly going to recommend that you pause the video before I get going on this problem so you can compare your answer to mine. An unknown liquid has a density of 1.32. 1.32. Density is equal to 1.32 grams per mil, right? And what is the volume if we have a mass of 14.7 grams, right? So what's the volume in, I don't have it. Excuse me one second, folks. You looking for the keys?
Yes, sir.
Mama drove it last.
Right.
I didn't drive it. Yeah, sorry. You have to keep looking.
Thank you.
Good luck. What is the volume of a 14.7 gram sample of liquid? All right, so my question is, what is the volume in mils if I've got 14.7 grams, right? So I'm going to have to take this equation right here, right? 1.32 grams is equal to 1 mil. And I'm going to make a conversion factor. Put grams on the bottom and mils on top because grams have got to cross off. Let's put a number in there now. It's 1.32 grams per 1 mil. So this is going to be 14.7 divided by 1.32. There are 3 sig figs up top, 3 sig figs down below. So my answer is going to have to be written to 3 sig figs. Now I don't have my calculator with me, so I'm going to go over here to Google, and I'm going to do 14.7 14.7 divided by 1.32 equals 11.136. 11.136. Let's go back over here. And I can only write this to 3 sig figs. So that number is less than 5. So this is going to be written as 11.1 mils. Okay, and there is my answer. All right, so in review of this chapter, let's just look at this concept map real quickly. We started out with measurements, okay? Started out with measurements, and then we talked about measured numbers. Measured numbers have significant figures that oftentimes require rounding of numbers, and if using a calculator, they might include adding zeros, okay? We talked about metric units. We talked about metric units. And metric units are for measuring things like these things: time, length, mass, volume, and so on. And we also talked about prefixes, which help us with our metric units. And we need these for problem solving. We used some examples then. We didn't talk about specific gravity, but we used some examples that derive from mass and volume, and those were density. All right, so let's get ready for Chapter 3.